So I was just playing with some settings. Box 3.1, Tom in the natural world. We have seen how Tom can support collaboration and that humans are exceptional in the natural world, not only in the extent of these collaborations, but also in the variety of forms they can take. Racco Z 2022. But is Tom uniquely human? Whenever scientists propose something unique about the minds of humans, Tom, culture, language, this usually provokes other scientists to look for fragments of the ability in other species, sometimes revealing that we are not so special after all. Decades of such research on Tom has revealed that other apes and even some birds may have some basic form of Tom, such as appreciating that others have goals. But they tend to lack the advanced Tom of a 4-year-old human child, such as understanding false beliefs. Martin and Santos, 2016. It seems our nearest living evolutionary relatives are essentially stuck at the 9-month-old human stage of Tom. This may be related to what they are using their Tom for. Non-human primates tend to use their basic Tom mainly for competing and manipulating others rather than also for communication or cooperation, as children do. For example, in primates, grooming not only has benefits for the one being groomed, the groomer also benefits from reduced stress. And because such grooming is reciprocated, they benefit from reduced parasites too. When primates console others, they are likely to receive less aggression themselves. And when apes do share food, it tends to be that they have been harassed into doing so, or else the food has been begged for by others. Two chimpanzees spontaneously cooperating to carry a log or working together to fashion a tool are very unlikely events. Tomasello et al. 2005. So it seems humans have both the motivation to see collaborative opportunities where other species might see only competitive ones, and the cognitive ability with Tom to allow us to put those motivations into practice. Precisely when Tom emerges in children's development is still widely debated among researchers. This is because estimates of when a capacity emerges in development depend partly on how we measure it. For instance, we can ask children, "Where do you think Sally will look for a marble?" and then record what they say, e.g. in the box, or where they gesture, e.g. pointing at the box, or even where they look, e.g. their eyes gaze focuses on the box longer than the basket. We will explore this looking time method further in chapter 6 when we explore false beliefs across cultures. Each one of these methods places different demands on children. For example, looking requires less effort than pointing, which requires less effort than speaking. Not all of this effort is associated with Tom, however. For example, a spoken response might require a child to know something general about who did what to whom of grammar. We need to be cautious, therefore, about the timeline of development. It might not just be the development of Tom we are measuring, but also the ability to meet the demands of the test. In general, the lower the demands of the test, the earlier we have been able to establish the existence of Tom ability. For example, by carefully recording where infants look and how long, researchers have found evidence that quite sophisticated aspects of Tom, like false belief understanding, are present from a much earlier age than we traditionally thought. Anushi and Bilarjan, 2009, Southgate et al., 2007. These measures can be controversial, though, as they are more implicit. The tests become the more inference we make about what children know. Do we consider a child looking at the correct answer to be as strong as a piece of evidence as they're saying the correct answer? Sometimes the same child in the same test can give different answers depending on which method we use to reach a concise consensus on these kinds of issues. Researchers across the world have established large-scale collaborative ventures like the Many Babies Project. This global consortium of researchers aims to test theories of infant development across a wider range of ages, experiences, languages, and cultural backgrounds than a single team of researchers ever could. By showing their results and being more transparent about their methods, the researchers want to establish which findings can be consistently replicated across different contexts. In general, the relative ordering of abilities, e.g. basic Tom before advanced Tom, is less controversial than the obsolete time of acquisition. Ability X emerges at the time point Y, where any particular skill falls on the timeline of development is more likely to change subject to the method we use and the technologies we invest to test it. For example, eye gaze trackers represent a comparatively recent innovation, and it's unknown how the next technological advance will alter our understanding of developmental timeline. It is important to note that this feature of research is not specific to Tom, but is of significance to child development more generally. Key point: when a capacity is estimated to emerge in development, partly depends on how we measure it. Summary: Tom is the capacity to picture the world from another person's point of view, what they see, know, want, desire, or believe. By around 9 months of age, infants show a basic Tom ability, understanding that other people pursue their own goals and can have a different perspective on the world than they do. Dyadic and triadic social interactions are important contexts in which children learn about the minds of others. By around 4 years of age, infants develop a more advanced Tom ability, being able to hold mutually incompatible ideas about other people's beliefs, their own knowledge, and reality. Acquiring Tom has far-reaching social consequences for children's development. Tom helps people coordinate their intentions towards common goals and allows complex cooperation. When a capacity is estimated to emerge into Development partly depends on how we measure it.